Hi everyone, in this video I'm going to discuss the concept of interquartile range and box plots. Interquartile range or IQR and box plots. Okay, let's first talk about interquartile range. So what's interquartile range, IQR? It represents the range of the middle 50% of your data, right? So it's the range of the middle 50%. So it tells you the range of middle 50% data. Okay, cool. Before we talk about how we find this range, I want to first give you some terms that we need to use. First, Q1 or the first quartile, it represents the first 25% of your data. Okay, so it's the first 25% of data. Q2, or it's just your median, it's the first 50% of your data. Okay, and then Q3, or the third quartile, is the first 75% of your data, right? So if we have Q1, Q2, and Q3, then we can easily find IQR because IQR is the middle 50% of data. It's the range of the middle 50% of data, which means that it's just Q3 minus Q1, right? So if you want to find your IQR, it just equals to Q3 minus Q1. Okay, so that's how you'll find the range of the middle 50% of your data. Let's go ahead and do an example and to demonstrate to you how you're going to find your IQR here. So example 1, even, right? Even means you have even numbers of data points. So let's say 13, 5, 9, 8, 10, 3, 6, and 6, right? It's just like finding a median. When you find your IQR, you have to rearrange your data, right? That just makes everything clear for you to do. So I want to rearrange my data. So it becomes 3, 5, 6, 6, 8, 9, 10, and 13, right? Okay, good. What we need, right? We need Q1 and Q3. If you have even numbers of data points, it's kind of easy, or easier in this case. You are just going to separate your data set into 2 parts, right? First 4 and last 4 here. And then you want to find Q1 and Q3, right? Remember, Q1 is the first quartile, which means that the first 25% of data, right? Now you see inside this bracket, you have 4 numbers, right? And then the first 25, it should be in the middle between 5 and 6, right? So that goes back to the concept of if you have even numbers of data points and you want to find your median. So in this case, we are going to take the average of the 2, right? In this case, the average of 2 equals 5.5. And you do the same for the last 4 values. So in this case, this will give us 9.5. So this is your Q1 and this is your Q3, right? Now, since we have Q1 and Q3, it's easy to do the next step. IQR interquartile range, which is equals to Q3 minus Q1 equals to 9.5 minus 5.5 equals to 4. So in this data set, the range of the middle 50% of the data, or your interquartile range, IQR, is 4, right? So 4 is the answer here. Good. Next, we're going to do an example with odd numbers of data points. Okay. Example 2, odd numbers of data points in this case. 6, 14, 8, 8, 16, 2, 18, right? I'm going to follow the same steps. I want to rearrange it first. So, no, not the brackets yet. 2, 6, 8, 8, 14, 16, and 18, right? Since you have odd numbers of data points, right? So the one in the middle, this is your median, right? But for the purpose of this question, you don't need that value here. So basically, conceptually, so you just take out 8 and then you cut the data into half. Okay, cool. And again, Q1 is the median of this set. Q3 is the median of this set. In this case, 6 is our Q1 and 16 is our Q3. So in this case, our IQR equals to Q3 minus Q1 equals to 16 minus 6 equals to 10, right? So 10 is our interquartile range for this set of data. Okay, good. Next, I want to talk about box plots, right? So what's box plots, right? Box plot is a plot that kind of represents or shows you the distance between your data, and it's also very good to show outliers in your data set. So next, we're going to talk about box plots. Box plots, I'm going to say it represents or shows distances between data, and also it shows outliers. Okay, very good. So we know what box plots are useful for. Next, I'm going to show you how to construct one. For box plot, the first thing you want to do is, or not the first thing you want to do. So what I'm doing here is to show you the components of a box plot. So I'm going to do a box first. Let me move it in the middle, a little bit more in the middle. Okay, so box here. Okay. So first you have a box here, and then there's a line in the middle. So the value here is your first quartile, Q1. The line in the middle represents the value for median, or Q2, and then the value here is Q3. Okay, cool. Now, you want to say that I want to use this box plot to show if there are any outliers in my data sets. Right? Okay, cool. So, if there's outlier, you say X to represent, cross represent. This is outlier. Okay, this outlier. But how to decide if a data point is an outlier, right? to decide, we will have a rule to do it. So how to decide outliers. Okay, cool. So we'll have a range, right? So if a data point is not in this range, then it's an outlier, right? So data point not in the range, then they are outliers. Okay, then they are outliers. Okay, cool. And what's the range? The range is your first quartile, subtract 1.5, multiply your interquartile range, right? So that's the left, and then the right is your Q3 plus 1.5 times your IQR. Okay, so if data points that's not in this range, then it's an outlier. Okay. So how you're gonna show it on the graph or on the plot? Right, on the plot, there's one part that's missing. Is the two lines here. Okay. Okay. So what are these two dots? Right. So these two dots on each side of this line represents. So this one is the minimum value of your data set that's not an outlier. Min without outlier. Okay, and this one is the max value without outlier, right? So this range here, right? So this line, if there's a point, then the point kind of stops it, right? If you take out all the outliers, and the minimum value is here, it's this dot. If you take out all the outliers, the maximum value is here. Where if any value is less than the range here, you will put an X here, and that's your outlier. If any value that's bigger than this range here, you put an X here. And then the range here, until you hit an outlier, the range here is calculated by Q1 minus 1.5 times IQR. And this one, the range here is Q3 plus 1.5 times IQR. Okay, so any value that's outside or less than this value here, outlier. Bigger than this value here, outlier. Okay, cool. So let me quickly capture what's in here, in this box here, right? You have your median in the middle, Q1, Q3, and then you kind of calculate the range first. If a data point is less than this value here, outlier, put an X for that. If a value is bigger than this, you put an X for that. And then this line here connects the max value without or taking out outliers. The minimum value when you take out all the outliers. Okay, cool. Let me give you an example to demonstrate to you how to do a box plot. Okay, example 9, 15, 36, 2, 11, 7. Okay, so we want to rearrange it first. 2, 6, 7, 9, 11, 15, and 30, right? same methods with odd numbers of values here. So this one in the middle, 9 is in the middle, so this one is our median. Cut the data in half. This one is our Q1, and this one is our Q3, right? Right away, we already have 3 main components that we need, right? Q1, median, and Q3. Next, I want to draw or calculate first. Calculate the outlier range, right? Calculate outlier range, right? To calculate outlier range, you're right. Because to calculate your outlier range, you need one value that's important. It's interquartile range. That's equal to Q3 minus Q1. In this case, it's 15 minus 6 equals to 9 here. Okay, very good. Let me do it on this side. Okay, so outlier range goes to Q1 minus 1.5 times IQR, Q3 plus 1.5 times IQR. Okay, so let's just plug in the numbers here, and in this case, it goes to 6, right? 6 minus 1.5 multiplied by 9, and here's 15 plus 1.5 times 9. This equals to 6 minus 13.5, 15 plus 13.5, and the range is minus 7.5 and then 28.5. Okay, cool. And now we want to see if there's any outlier in our data set here. Okay, so are there any number that's less than negative 7.5? And the answer is no, right? The smallest number we have is 2. So we don't have a small outlier, right? So check. Do we have a big outlier, right? The answer is yes. Look at the 30 here, right? 30 is outside this range. So this is an outlier. So 30 is an outlier. Okay, cool. So now we have all the information that we need here. Okay, cool. So yeah, let me do it from this side here. Okay, so we can erase this. Okay, perfect. With all the information, and we're ready to do a box plot here. So first you want to make a scale that kind of fits your data set, right? So here I want to do, say, the max, or I need a place to put my 30 as my outlier. So let's do 0 to 30, or say 35. And then the scale I'm going to use is 5. So let me do a line, right? It's important that you have a good scale here. So let me start with 0, and then 5, 10, 15, 20, 25, and 30, right? Of course, right, if you do it on paper, you can do it better scale. Let me see, 35 here. Okay, good. So do the median first. Well, I mean, how you do it, the ordering, how you do it, it's totally personal preference, but I like to start with the median here. So median is a 9, so it's about here, right? Do a line here, and say this is 9, okay? And then first quartile is 6. So 6 is about here. So I'll do a 6 here. Okay, good. And then third quartile, 15. Right, it's right on 15 here. Okay, and then connect them and make a box. Okay, good, good. And in this case, I'm gonna just go ahead and do it the outlier. Put an X here. This is our outlier. It's 30. Okay. And then I'm to the left and I'm going to the right. Remember, there's a line connecting to a dot. And then the dot here represents the minimum value when you take out all the outliers. In this case, we kind of don't have outliers here. So 2 is the minimum value that we have. So 2, put a dot here, put 2, and then connect it to it. Okay, and that's 2. Okay, now the question is that I purposely show you this example is this one can be a little bit tricky, right? So if I take out all the outliers, right, means I take out 30, 15 is my max value here, right? But then my max value 15 is also my Q3. How am I going to do this? So in this case, if you don't have a max value that's different than your Q3, we're going to do a line without the dot, right? What it means is that I'm going to do the line here all the way to the left side or left most value, or no, the right most value or the biggest value of my range. So I'm going to do a line. It's about here, right? Yes. So I'm doing a line and say here's 28.5, but there's no dot here, right? No dot because there's no value here. Okay, cool. So what it says is that, okay, even though I don't have a point to be my max value to kind of close up this box plot, then this line represents the range where any values that's bigger than this point here is an outlier. Okay, cool. Where if we have a max value, you know, then the max value will be a dot somewhere in this line here. Okay, good. So yeah, so this is a complete box plot for this data set here. Very good. So in this video, right, we talked about how you calculate your interquartile range and also how to plot a box plot. Okay, so this concludes this video and I'll see you in next video. Thank you for watching.